So I have my IntelliJ open. Let's start solving this problem. I will take the same method name as given here in lead code and type it here. Okay. Okay. Now, as we have already calculated the formula here, so we apply the same. But before that, we create this DP array with one extra row and extra column and mark it as max number. This max can be greater than 100, but I've just taken that as max. So let's implement this. First of all, let me take the number of rows, which is grid.length. Similarly, I will take number of columns as first row length, right? So it's 2D array. So I will not create this like just to optimize the space. I will just use one 1D array for each row I'll calculate one row at a time. So I'll just create 1D array and then we will keep on calculating for each rows until we reach to the 0th row, where with our row 0 would give us the final solution. Just to optimize the space, I will not use a 2D array, just one array. So this would be my row which I am dealing with. So it would be calls plus 1, right? Calls plus 1 because we have one extra column here where we are putting this max as our base case. Okay, and I will fill all of them with integer.max value. Right, I'm just treating max as an integer.max value. And now we have to, as we have noticed that to make this one, our base condition work for the bottom cell, right bottom cell, either this can be 0 or this can be 0. So let's start with this as 0. Okay, so this would be row calls minus 1 is equal to 0, right? This is for our base condition to work. Okay, because columns is say 3 minus 1 is 2, so that's why this second index cell is we have put as 0. Now let's iterate from all this cell from here till 0, right? From starting from 3 to 0. So now because we have already filled our last row, so we have already covered this part. Now we move to this row, that is starting from 2. Okay, so I just use a for loop here. So int I is equal to rows minus 1. The rows number is 3 and we have to start from here. It is 2, so rows minus 1, and I is greater than or equal to 0 because 0 will give me the final solution row. And I minus. And now I will create a temporary, just mark a temporary next row. Next row is where we are calculating this, and we'll keep on calculating the row based on next row. So let's see how it works. So I will create this call plus 1. And so here, this next row represents this row. And now we know that the last third index is max. So I will mark this next row as max. Next array calls is equal to integer dot max value, right? So, and now we move from this cell to this cell, that is calls minus 1 to 0. And for each of this cell, we apply this formula that we have reduced in our last video. So let me do that again. For I will mark j as calls -1, j greater than equal to 0, and then j minus minus. And just, so again, calls -1 is 2, and then we move to 0. And then we calculate each item. Next row j is this item, this item, this item, which is the formula which we have calculated here. This is grid I and minimum of this and this. If I calculate this, minimum of this and this. Okay, so it would be grid of I j plus I use math.min minimum of row of j. Row j is this one, because j is still cos -1. Cos -1 is 2. We are our row is stored here. So this the initial value that we created as a row, and the current row which we are calculating is next row. So a row already contains the bottom row here, and we are taking this value, row of j, or for the next row, j plus 1, right? Next row j plus 1 is the same row, and this one, right? This is all about the for loop. And then once we calculate the next row, then we update our previous row to the next row. So again, if you consider this for loop, it will move from this to this position. Our row is pointing to this row, and our next row will be pointing to the first one. And we do the same formula to calculate for the next row. And finally, once we are done with all these values, then we update the row to this, and then the next row will be calculated for this one. So this is how the whole loop will work. And finally, once we calculate the final row value with I is equal to 0, after that, our solution is here as at the row of 0. So we'll just simply return this, return row of 0. So that was all the formula about. We just implemented in Java the same algorithm. Now let me run this for the sample case. Before that, let me first of all create this, because we have to create a 2D array. So I will just use the initialization here. I will create a grid. It's equal to new int, like this, right? And let me take this grid. So in Java, when we initialize a 2D array, we just need to use 2 curly braces here, like this. Okay, and then I'm just replacing all these square brackets with curly brackets. This is how we initialize a 2D array or an array in Java. Okay, so this is same as we have got a 2D array with these elements as given in the example here. And now I will simply put this minimum path sum and pass the grid value here. Let's run this. So answer is correct. Let me copy the same code and run it in lead code. So it worked well. It's efficient as well. So now let's quickly calculate the time and space complexity. So for the time complexity, we can see that we are using 2 for loops here, and for loops are like the row and the grid given here. So it would be O of m into n, right? Because m is given as the row, a number of rows here, and n is the number of columns. So this is the time complexity. And for the space complexity, because we are not creating 2D array, we have optimized the space here by just using 1D array with the number of columns here. So it would be O of n. So this is the time and space complexity of this problem. So guys, this was all about the minimum path sum. So, and today we have completed 20 problems, 20, one of the most popular problems for dynamic programming problems. In the next video, we will proceed with the 21st problem of this tutorial series, which is count vowels permutation. This is also a very interesting problem to solve. So see you all in the next video when we solve this problem together.